Hey guys, alright, I'll start with explaining how to divide polynomials by a binomial. And there are three methods that are basically the same way to do that, just represented like differently in terms of the visual aspect. So the first method I'll show you is the polynomial line division. And so you start off by setting up your box like in 3rd grade. And notice that I put a 0x, and that's important as a placeholder. So it's like not included in the expression, but you should include it here. And then see why later. And so here's my first step. I multiplied x plus 2 by 3x squared to cancel out the 3x squared. And naturally I had to do the same for this guy, the 2. And so I was left with negative 4x squared. And then I brought down the 0x, all that doesn't really matter. And then my next step is to, here I multiplied by negative 4x. Like I multiplied negative 4x by both terms to get this expression, and I subtract it again, and I'm left with 8x. And then I brought down the 10, which is here is important. Here I multiplied by positive 8, and then I got a remainder of negative 6. And the way I represent that is by then subtracting by 6 over x plus 2, because we're dividing by x plus 2. And so boom, that's the answer. So the next method is the area model, and each of the individual visual boxes in the model add up to the quotient. Okay, so we do basically the same thing as before. I write 3x squared to multiply to get 3x cubed. And I also multiply by the 2, so 6x squared. And then here to get 2x squared, I subtract by 4x so that I get 4x squared, because note that these diagonals have the same term, and so they need to add up to get this term. And then negative 8x. Then I want 0x, so I add 8, no x. So I get 8x, and then I get 16 over here. And then since we want 10, the remainder is equal to negative 6, and ignore this box. So minus 6 over x plus 2. So the last method is synthetic division, and I only recommend this if a equals 1 for the binomial divisor of ax plus b. And so I start with, since the divisor is x plus 2, let's say that equal to 0, and then if that's the case, then we're going to work with the number negative 2. So we're going to put that up here, negative 2. And then this is the multiply column. And then here, we're just going to add stuff. Okay, so for starters, we're going to put the number 3 down here. And then we're going to multiply by 3 times negative 2, and then put it over here, negative 6. And then, like I said, we're going to add here, so negative 4. And then 8, and then add 8, and then negative 16, and then r is equal to negative 6. Then finally, after you do that work, you put in the variables saying like the exponents are 1 less than each of the ones in here. And here's the polynomial remainder theorem. That's pretty important. And then these algebra identities, especially the difference in the squares, that's important.